Is artificial intelligence an existential threat to humanity? After the point at which computers and software reach superintelligence, the so-called singularity, where they can do everything we can do better and faster and self-improve with every iteration, will humanity be at risk? We'll hear what some of the world's greatest thinkers, physicists, computer scientists, and programmers have to say on the matter. Whether they think this is a serious issue. After all, if computer superintelligence goes rogue, we won't just be able to unplug the internet.
We are fast approaching an event unprecedented in our history, a tipping point known as a technological singularity. When this happens, the world will change forever. A new chapter in human history will begin. In physics, the singularity is a point where gravity is so intense that even space and time begin to break down, like the Big Bang or the black hole. But it also refers to a time when computer power grows without limit, surpassing human intelligence, sweeping aside everything in its path. It may be 20 years away, it may be 1,000, but most experts agree the technological singularity is inevitable. The fear is, if it's uncontrolled, the results could be catastrophic. When the singularity arrives, we cannot predict what these super intelligent machines will do. They will have their own goals and stop at nothing to fulfill them. They may even choose to eliminate everything that stands in their path, including us.
I'm here to talk about existential risk in AI, so let's just dive straight into it. What's an existential risk? Well, it's a risk that's plausibly likely to annihilate Earth-based intelligent life, that's you or me, folks, or permanently curtail its potential. These are generally considered to be bad. The Future of Humanity Institute is part of the Department of Philosophy, but we spend a lot of time doing science. And these are the kind of existential risks that we look at in no particular order: pandemics, synthetic biology, nanotechnology, artificial intelligence, and nuclear war. Two types that we're not currently looking at are asteroid impact and environmental collapse, mainly because in relative terms, these are just not risky enough. For this talk, I'll be looking at artificial intelligence, how dangerous it can be. So what is AI? Well, first of all, it's not a Terminator, which is basically big muscles and no brains. I think this photo illustrates well that it's not the species with the big muscles that's the dominant one. To illustrate this, we have the brain of a chimp and the brain of a human. Chimpanzees have a population of 200,000 and use basic wooden tools. Humans have heavy industry, nuclear weapons, and are spread across the planet. And if the difference between these two is explained by brain size, what would happen if we went up a brain size? In fact, we don't need to speculate, because since the 40s, we've had computers which extend our own brains and have given us moon landings, hydrogen bombs, and unprecedented economic growth. So what would the next step be if we got a real AI here? Well, even if we just get human-level AIs, these things can be copied, can be trained. We can take the best of them and then we can network them together and form super committees with, say, Edison, Einstein, George Soros, Bill Clinton, Oprah, Plato, Goebbels, Bernie Madoff, and Steve Jobs. Each of them brilliant in their narrow domain, networked with each other, large databases, and running millions of times faster than any human. And this is what we can get with human-level AI. If we have something beyond that, well, the sky's the limit. From this AI's perspective, the internet and the human race are both useful resources. So, how bad could it be? Put simply, very, very bad. The actual reasons are slightly technical. There's lots of arguments. I encourage you to look at our website. But the best summary I can give here is that AIs are likely to be expected utility maximizers that completely ignore anything that they're not specifically tasked to maximize. And it's very hard to get around this problem. Do what we mean is not something that is easy to code. Let me just show you some very bad approaches, like we might want to do an AI to prevent human suffering. Oh, how nice. This will be interpreted as... And the AI will fight you if you try and prevent it from killing all humans, because anything with not all humans dead means more human suffering. Let's be a little smarter than that. Keep humans safe and happy. I think you can see where this is going. Now, someone wants an AI specialist propose this as a serious proposition, that we should train AIs on human smiles and generalize. Well, I think if we started with that, we know what the future of the universe would start looking like.
Well, it used to be that if you wanted to get a computer to do something new, you would have to program it. Now, programming, for those of you who haven't done it yourself, requires laying out in excruciating detail every single step that you want the computer to do in order to achieve your goal. Now, if you want to do something you don't know how to do yourself, then this is going to be a great challenge. So this was the challenge faced by this man, Arthur Samuel. In 1956, he wanted to get this computer to be able to beat him at checkers. How can you write a program, lay out in excruciating detail how to be better than you at checkers? So he came up with an idea. He had the computer play against itself thousands of times and learn how to play checkers. And indeed it worked. And in fact, by 1962, this computer had beaten the Connecticut state champion. So Arthur Samuel was the father of machine learning, and I have a great debt to him because I am a machine learning practitioner. I was the president of Kaggle, a community of over 200,000 machine learning practitioners. Kaggle puts up competitions to try and get them to solve previously unsolved problems, and has been successful hundreds of times. So from this vantage point, I was able to find out a lot about what machine learning can do in the past, can do today, and what it could do in the future. Perhaps the first big success of machine learning commercially was Google. Google showed that it is possible to find information by using a computer algorithm, and this algorithm is based on machine learning. Since that time, there has been many commercial successes of machine learning. Companies like Amazon and Netflix use machine learning to suggest products that you might like to buy, movies that you might like to watch. Sometimes it's almost creepy. Companies like LinkedIn and Facebook sometimes will tell you about who your friends might be, and you have no idea how it did it. And this is because it's using the power of machine learning. These are algorithms that have learned how to do this from data rather than being programmed by hand. This is also how IBM was successful in getting Watson to beat the two world champions at Jeopardy, answering incredibly subtle and complex questions like this one. This is also why we are now able to see the first self-driving cars. If you want to be able to tell the difference between, say, a tree and a pedestrian, well, that's pretty important. We don't know how to write those programs by hand, but with machine learning, this is now possible. And in fact, this car has driven over 1 million miles without any accidents on regular roads. So we now know that computers can learn. And computers can learn to do things that we actually sometimes don't know how to do ourselves, or maybe can do them better than us. One of the most amazing examples I've seen of machine learning happened on a project that I ran at Kaggle, where a team run by a guy called Geoffrey Hinton from the University of Toronto won a competition for automatic drug discovery. Now, what was extraordinary here is not just that they beat all of the algorithms developed by Merck or the international academic community, but nobody on the team had any background in chemistry or biology or life sciences, and they did it in 2 weeks. How did they do this? They used an extraordinary algorithm called deep learning. So important was this that, in fact, this success was covered in the New York Times in a front-page article a few weeks later. This is Geoffrey Hinton here on the left-hand side. Deep learning is an algorithm inspired by how the human brain works. And as a result, it's an algorithm which has no theoretical limitations on what it can do. The more data you give it and the more computation time you give it, the better it gets. The New York Times also showed in this article another extraordinary result of deep learning, which I'm going to show you now. It shows that computers can listen and understand. So deep learning is this extraordinary thing. It's a single algorithm that can seem to do almost anything. And I discovered that a year earlier, it had also learnt to see. In this obscure competition from Germany called the German Traffic Sign Benchmark, deep learning had learnt to recognize traffic signs like this one. Not only could it recognize the traffic signs better than any other algorithm, the leaderboard actually showed it was better than people, about twice as good as people. So by 2011, we had the first example of computers that can see better than people. Since that time, a lot has happened. In 2012, Google announced that they had a deep learning algorithm watch YouTube videos and crunch the data on 16,000 computers for a month. And the computer independently learned about concepts such as people and cats just by watching the videos. This is much like the way that humans learn. Humans don't learn by being told what they see, but by learning for themselves what these things are. Also in 2012, Geoffrey Hinton, who we saw earlier, won the very popular ImageNet competition, looking to try to figure out from 1.5 million images what they're pictures of. As of 2014, we're now down to a 6% error rate in image recognition. This is better than people again. So machines really are doing an extraordinarily good job of this, and it is now being used in industry. So we now have computers which really understand what they see and can therefore search databases of hundreds of millions of images in real time. So what does it mean now that computers can see? Well, it's not just computers can see. In fact, deep learning has done more than that. Complex, nuanced sentences like this one are now understandable with deep learning algorithms. As you can see here, this Stanford-based system, showing the red dot at the top, has figured out that this sentence is expressing negative sentiment. Deep learning now, in fact, is near human performance at understanding what sentences are about and what it is saying about those things. Also, deep learning has been used to read Chinese, again, at about native Chinese speaker level. This algorithm developed out of Switzerland by people, none of whom speak or understand any Chinese. As I say, using deep learning is about the best system in the world for this, even compared to native human understanding. So I'm very excited about the opportunities. I'm also concerned about the problems. The problem here is that every area in blue on this map is somewhere where services are over 80% of employment. What are services? These are services. These are also the exact things that computers have just learned how to do. So, 80% of the world's employment in the developed world is stuff that computers have just learned how to do. What does that mean? Well, it'll be fine. It'll be replaced by other jobs. For example, there'll be more jobs for data scientists. Well, not really. It doesn't take data scientists very long to build these things. For example, these 4 algorithms were all built by the same guy. So if you think, oh, it's all happened before, you know, we've seen the results in the past of when new things come along and they get replaced by new jobs, what are these new jobs going to be? It's very hard for us to estimate this because human performance grows at this gradual rate. But we now have a system, deep learning, that we know actually grows in capability exponentially. And we're here. So currently we see the things around us and we say, oh, computers are still pretty dumb. Right? But in 5 years' time, computers will be off this chart. The machine learning revolution is going to be very different to the industrial revolution, because the machine learning revolution, it never settles down. The better computers get at intellectual activities, the more they can build better computers to be better at intellectual capabilities. So this is going to be a kind of change that the world has actually never experienced before.
We're seeing the successful development and demonstration of general-purpose AI. Its name is AlphaGo, and it was made by Google's DeepMind division. The AlphaGo AI algorithm beat a human at the world's hardest game. This is a historic moment in computer science and artificial intelligence. So what exactly is Google DeepMind? Where did it come from? And what can the company's artificial intelligence actually do? In this video, we'll find out.
A computer program beat a human brain at the ancient Chinese board game of Go. The final score 4-1, a triumph for artificial intelligence equipped with human intuition.
The victory of a program over a human in the ancient board game Go has sparked intrigue and, in some cases, concern. It shows that a machine has approximated human intuition and outsmarted the best human brain in the game. It's something that scientists hadn't expected to happen for at least another decade. And it's a giant leap for artificial intelligence, showing that machines can learn on their own.
I think maybe the game ended.
No, I don't think so, because it looks like Lee is still counting.
No, I think he resigned.
Wow, I think you're right. Wow. Wow, wow, wow.
This was the moment a computer called AlphaGo beat a master of the ancient Chinese game Go.
Weird place. I think he...
It's not the first time a grandmaster's been humbled by a machine. But what makes AlphaGo different is that it's the first demonstration that machines can truly learn and think in a human way. AlphaGo's victory shocked experts in the artificial intelligence community. Many thought such an event was at least a decade away.
So firstly, a few questions. Why is this important and what's all the fuss? AlphaGo shows that machines can really learn. How so? Well, instead of using brute force to calculate all the moves it could make, like previous AIs, AlphaGo used reinforcement learning and neural networks to mimic the learning process of a human brain. Keep in mind that the ancient Chinese game Go has as many more possible moves than chess as there are atoms in the entire universe. So there's no way of just calculating every possible move on the board. That's practically impossible. For this reason, Go is the holy grail of AI, and learning to do such a task from scratch is a huge feat. Further to this, DeepMind's creators say that the algorithm can learn many more things without alteration or guidance. In other words, the AI is general purpose.
We always used to talk about, well, if we could eventually crack Go and have a program that could beat the world champion, then we must have invented some generic, general-purpose algorithm. So maybe we're on the cusp of all of that. If you ask a great Go player why they played a particular move, sometimes they'll just tell you it felt right. So the one way you could think of it is that Go is a much more intuitive game, whereas chess is a much more logic-based game.
So what is DeepMind? Google DeepMind is a British artificial intelligence company that was founded in September of 2010 as DeepMind Technologies. It was renamed when it was acquired by Google in 2014 for $500 million. Interestingly enough, this was just after Facebook had just finished negotiations with them in 2013. And another fun fact, Elon Musk is actually an investor in the company, just to keep an eye on them, of course.
Shall we play a game?
DeepMind claims that their system is not pre-programmed and it learns from experience using only raw pixels as data input.
So the way we start off training AlphaGo is by showing it 100,000 games that strong amateurs have played that we've downloaded from the internet. And we first initially get AlphaGo to mimic the human player. But of course, ultimately, we would like AlphaGo to be stronger than human amateurs and compete with the top professionals. So the way we do that is, after we take that first version that's learnt to mimic human play, we then allow it to play itself 30 million times on our servers, and using reinforcement learning, the system learns to improve itself incrementally through avoiding its errors and increasing and improving its win rate against older versions of itself. And after all these games, then you end up with a new version that can beat the old version, the original version, around 80–90% of the time.
Technically, the reinforcement that DeepMind uses is model-free, meaning that it doesn't need a structure or set of rules to learn. According to MIT's take on the Google algorithm, the neural network, in theory, should be able to access an external memory in a manner that mimics the short-term memory of the human brain. In a way, it almost seems like our brain's design might be the most efficient way for the creation of local intelligence. Who would have guessed? So that's all good. What about this general purpose term? What does that actually mean? Well, because the machine learns from raw experience and data, it can perform well across a wide variety of tasks, straight out of the box. Okay, so that's enough talk. Let's watch the system in action, learning how to play Breakout. And remember, the machine didn't have any foreknowledge as to what task it was going to complete. It had to figure out how to do everything only from its own experience.
Is the machine before training. So this is literally the first time the machine has ever seen this data stream, and it's controlling the green rocket here, and you can see it's losing its 3 lives immediately. So it's basically terrible at the game, as you would expect. Now, after training, this is like overnight. We leave it playing the game overnight on a normal computer, so for about 8 hours. You come back in the morning, and now it's superhuman level. So now the machine can play Space Invaders better than any human can. It's modeled the world, the game world, so well. It knows where the Space Invaders will be ahead of time. So as the Space Invaders speed up, when you get less of them on the screen, it fires the final shot as a kind of predictive shot of where the final Space Invader will be in a few seconds' time.
But the cool thing is, after understanding how to play a few games, it will be able to transfer this knowledge and understanding across more games. At the moment, DeepMind is currently playing games from the 1970s and 80s, but work is currently being done on more complex 3D games such as Doom, which appeared in the early 90s. Should we be worried? In the thousands of years of meaningful civilization, our modern existence right now is an anomaly. We've overcome the limits of nature with technology that helps us facilitate such a lifestyle. But artificial intelligence is different. The reason being, AI is the first thing humans have created that tends to function in a way that we can't predict. So, should we worry?
What happens when a computer can think just like you? Or what happens when a computer can think better than you when super artificial intelligence emerges? Well, if both Elon Musk and Stephen Hawking are afraid of something, should we be too? The Avengers, for one, do not welcome our robot overlords. In Age of Ultron, Tony Stark accidentally creates a super intelligent AI that considers itself superior to human beings, which of course warrants their destruction. Ultron, as the AI is known, is self-aware, self-improving, and psychotic. This scenario certainly sounds scary, but let's start from the bottom and work our way up to the top of evaluating this robo-apocalypse. Not all artificial intelligence is that intelligent. You probably interact with one form of artificial intelligence every day. You probably have weak or narrow AI in your pocket. If you have a voice recognition app on your smartphone, for example, you have weak or narrow AI that is focused on one task or a narrow set of tasks. But the weak AI in something like Siri is unlikely to take over the planet like Ultron. Siri, take over the planet.
That may be beyond my abilities at the moment.
See? Totally fine. At the moment? What do you mean at the moment? Even something like IBM's Watson, which has bested human players at Jeopardy, is still a form of weak AI, even though it can pull answers to complicated questions from mountains of data in seconds. It is still not self-aware, and it cannot perform any functions other than those it was programmed for. But this doesn't mean that weak AI can't be dangerous. Weak AI may only be able to perform a narrow range of tasks, but it can still outperform any human at the tasks that it does perform. Think of a weak AI, just some lines of code that was programmed specifically to infiltrate other systems and to overload electrical circuits. Before we even knew what was happening, the AI would spread like a virus and leave sizzled circuits in its wake before we even knew what it was. In other words, in the wrong hands, even weak AI can be a problem, but the next step up from weak AI is even worse. Have you ever heard of the singularity? In 1958, mathematician John von Neumann coined the term to describe exponential technological advancement to a point where human life as we know it would cease to exist. It would get to a point where we have no idea what would happen, like the physics at the infinitesimal end of a black hole. Many futurists and thinkers like Elon Musk and Stephen Hawking are worried that strong AI that can think like us and opposed to weak AI, is what will bring us to the singularity, and soon. When a machine can fully emulate all aspects of human thought, the worry is that it will become sentient or self-aware and then infinitely self-improving. From there, humans would no longer be the most intelligent things on the planet, and this superintelligence may decide that humans aren't that useful to keep around, like Ultron does. Of course, while there are many experts who fear the singularity, none of them knows when it is coming. Ray Kurzweil, perhaps the most visible of these experts, thinks that 2045 is the date when Skynet finally becomes self-aware. And many AI researchers think that this is going to happen at least within the next century, but as early as 2 to 3 decades from now.
The internet has speeded up communication and research, but at the high price of invasion of privacy.
And is the internet and modern forms of communication in general, is that a purely positive development, or are there things about it that actually worry you?
The internet has brought a lot of benefits, but it has its drawbacks and dangers, such as pornography and threatening messages. According to the new head of GCHQ, the internet has become the command center for criminals and terrorists. More must be done by the internet companies to counter threat, but the difficulty is to do this without sacrificing freedom and privacy.
Now, when you watch software engineers and machine learning experts at work, as they have been on this project, how far along the path to artificial intelligence do you think we are?
The primitive forms of artificial intelligence we already have proved very useful. But I think the development of full artificial intelligence could spell the end of the human race. Once humans develop artificial intelligence, it would take off on its own and redesign itself at an ever-increasing rate. Humans, who are limited by slow biological evolution, couldn't compete and would be superseded.
All this talk of technology, theoretical physicist Stephen Hawking, whom I'm sure you know, warned this week that technology could end up ending humanity at some point. Do you share that apocalyptic view of technology?
Well, I think it's something that it's not going to happen overnight. I do think we have to worry about it. I don't think it's inherent that as we create superintelligence that it will necessarily always have the same goals in mind that we do. You know, humans don't always have the same goal as other humans. So who gets control of the technology? How is it built in? I don't think there's a need to panic, but I think the dialogue along those levels, the people who say let's not worry at all, I don't agree with that.
Now, you've taken a lot of interest in artificial intelligence. This is becoming an artificially intelligent car.
Well, it's narrow artificial intelligence.
You've also expressed concern about where that's heading. Is that because you've looked at what that car can do and have thought, what happens if it develops a mind of its own? Why are you worried?
No, we don't need to be concerned about the cars. The car, this is, I mean, a car is not deep AI. It's a narrow use case. You know, we're not trying to build sentience into the car. It's just trying to look at the lines on the road and steer correctly. And I would consider that to be essentially a solved problem. It's just a question of refining the details of the technology and bringing that to market, and then improving the nines of reliability. So in order to have a self-driving car, you really have to have many nines of reliability. So it's 99.9999%, something like that, is how good it needs to be. Or, you know, let's say, to first approximation, you would want a self-driving car to be an order of magnitude safer than a human-driven car. And if you're like, okay, it's 10 times safer, then it's like there's no more doubt, there's no more debate about which one is safer. but it's still a narrow use case. The car is not going to develop consciousness or decide that they want to take over the world or something like that. I think we really need to be more concerned about deep AI. Yeah.
And why do we need to be concerned about that?
Well, I mean, because there are, I think, scenarios where if there's some vast intelligence that either develops a will of its own or is subject to the will of a small number of people, then we could have an undesirable future. I mean, if you want to read a real scary one, I'd say Harlan Ellison's "I Have No Mouth and I Must Scream" will give you nightmares.
You read a lot of science fiction. Is it giving you nightmares at the moment?
It has given me nightmares, yeah.
And are you generally, when you've been one of the prime movers about AI, I interviewed Stephen Hawking last year,
right.
Had similar concerns. Is that a short-term concern, or is it something way off that we don't need to worry about for a long time?
It's going to come faster than anyone appreciates. I think it's, with each passing year, the sophistication of computer intelligence is growing dramatically. I mean, I really think we're on an exponential improvement path of artificial intelligence. And the number of smart humans that are developing AI is also increasing dramatically. I mean, if you look at like the attendance at the AI conferences, they're doubling every year. They're getting full. I have a sort of a young cousin of mine who's graduating from Berkeley in computer science and physics, and I asked him, like, well, how many of the smart students are studying AI in computer science? And the answer is all of them.
Now, you're in 3 extraordinary industries. You're in electric cars, you're in rockets, and you're in solar energy. What unites you? What unites those 3 interests?
Well, what I'm trying to do is to minimize future existential threats, or to take whatever action I can to ensure the future is good. I didn't expect these companies to succeed. I thought they would most likely fail, particularly Tesla and SpaceX. I thought SolarCity had a higher probability of success. But in the beginning, I thought SpaceX and Tesla maybe had a 10% chance of success. And so I'm quite surprised, really, to see that that we're alive. It's great. I wasn't expecting that. I don't think most people understand just how quickly machine intelligence is advancing. It's much faster than almost anyone realizes, even within Silicon Valley, and certainly outside Silicon Valley, people really have no idea. So
why is that dangerous?
I mean, if there's a superintelligent, particularly if it's engaged in recursive self-improvement, if there's some digital superintelligence and its optimization or utility function is something that's detrimental to humanity, then it will have a very bad effect. It could be just something like getting rid of spam email or something, and it's like concludes, well, the best way to get rid of spam is to get rid of humans.
But why would we lose?
The source of all spam.
I know we've all watched Cal in 2001, but why would we lose control over our machines? There are no data points showing that our connection to machine has ever been loosened.
Actually, I think the thing to do would be to plot the progress of digital intelligence versus time, and then to maybe curve fit or extrapolate that progress and see where that leads.
But you're talking about machines that are not just intelligent, but have intentionality. Is that right?
They have the intention of their utility function, which
is what
absolute.
we programmed in, right?
Yes.
Okay.
But it can have unintended consequences.
artificial intelligence is just the next advance. Much more, to me, in an evolutionary way, than is VR. Because virtual reality, to me, is, well, it's a nice whistle, but it's not a profound thing. But the ability of these services to be able to serve you in ways that to you appears like magic, that's why artificial intelligence, when it relates to travel, when it relates to being able to essentially serve you without even your understanding how, and give you a result that delights you, that's magic.
Elon Musk says we should be scared. Should we be scared?
Yeah. If you take artificial intelligence to its natural conclusion, then in fact, you have smarter beings than we are who can walk and talk and kill and control.
I work with a bunch of mathematicians, philosophers, and computer scientists, and we sit around and think about the future of machine intelligence, among other things. Some people think that some of these things are sort of science fiction-y, far out there, crazy. But I like to say, okay, let's look at the modern human condition. This is the normal way for things to be. But if we think about it, we're actually recently arrived guests on this planet. The human species, well, like, think about if the world was created, Earth was created 1 year ago. The human species then would be 10 minutes old. The industrial era started 2 seconds ago. Another way to look at this, if you think of world GDP over the last 10,000 years, I've actually taken the trouble to plot this for you in a graph. It looks like this. It's a curious shape for a normal condition. I sure wouldn't want to sit on it. Now, let's ask ourselves, what is the cause of this current anomaly? Some people would say it's technology. Now, it's true. Technology has accumulated through human history. And right now, technology advances extremely rapidly. That is the proximate cause. That's why we are currently so very productive. But I like to think back further to the ultimate cause. Look at these two highly distinguished gentlemen. We have Kanzi. He's mastered 200 lexical tokens, an incredible feat. And Ed Witten unleashed the second superstring revolution. If we look under the hood, this is what we find. Basically the same thing, right? One is a little larger. It maybe also has a few tricks in the exact way it's wired. These invisible differences cannot be too complicated, however, because there have only been 250,000 generations since our last common ancestor, and we know that complicated mechanisms take a long time to evolve. So a bunch of relatively minor changes take us from Kanzi to Witten, from broken off tree branches to intercontinental ballistic missiles. So this then seems pretty obvious that everything we've achieved, pretty much, and everything we care about depends crucially on some relatively minor changes that made the human mind. And the corollary, of course, is that any further changes that could significantly change the substrate of thinking could have potentially enormous consequences. Some of my colleagues think we are on the verge of something that could cause a profound change in that substrate, and that is machine superintelligence. Like, artificial intelligence used to be about putting commands in a box. You would have human programmers that would painstakingly handcraft knowledge items. You build up these expert systems, and they were kind of useful for some purposes, but they were very brittle. You couldn't scale them. Basically, you got out only what you put in. And since then, a paradigm shift has taken place in the field of artificial intelligence. Today, the action is really around machine learning. So rather than handcrafting knowledge representations and features, we create algorithms that learn, often from raw perceptual data. Basically the same thing that the human infant does. The result is AI that is not limited to one domain. The same system can learn to translate between any pairs of languages, or learn to play any computer game at the Atari console. Now, of course, AI is still nowhere near having the same powerful cross-domain ability to learn and plan as a human being has. The cortex still has some algorithmic tricks that we don't yet know how to match in machines. But so the question is, how far are we from being able to match those tricks? A couple of years ago, we did a survey of some of the world's leading AI experts to see what they think. And one of the questions we asked was, by which year do you think there is a 50% probability that we will have achieved human-level machine intelligence? We defined human level here as the ability to perform almost any job at least as well as an adult human, so real human level, not just within some limited domain. And the median answer was 2040 or 2050, depending on precisely which group of experts we asked. Now, it could happen much, much later or sooner. Like, truth is, nobody really knows. Right? What we do know is that the ultimate limits to information processing in machine substrate lie far outside the limits in biological tissue. This comes down to physics. A biological neuron fires maybe at 200 hertz, 200 times a second. But even a present-day transistor operates at a gigahertz. Neurons propagate slowly in axons, 100 meters per second tops. But in computers, signals can travel at the speed of light. There are also size limitations, like a human brain has to fit inside a cranium, but a computer can be the size of a warehouse or larger. So the potential for superintelligence kind of lies dormant in matter, much like the power of the atom lied dormant throughout human history, patiently waiting there until 1945. In this century, scientists may learn to awaken the power of artificial intelligence. And I think we might then see an intelligence explosion. Now, most people, when they think about what is smart and what is dumb, I think have in mind a picture roughly like this. So at one end, we have sort of the village idiot. And then far over at the other side, we have Ed Witten or Albert Einstein, or whoever your favorite sort of guru is. But I think that from the point of view of artificial intelligence, the true picture is actually probably more like this. AI starts out at this point here, at zero intelligence, and then after many, many years of really hard work, maybe eventually we get to mouse-level artificial intelligence, something that can navigate cluttered environments as well as a mouse can. And then, after many, many more years of really hard work, lots of investment, maybe eventually we get to chimpanzee-level artificial intelligence. And then, after even more years of really, really hard work, we get to village idiot artificial intelligence. And a few moments later, we are beyond Ed Witten. The train doesn't stop at Humanville Station. It's likely rather to swoosh right by. Now, this has profound implications, particularly when it comes to questions of power. For example, chimpanzees are strong. Like pound for pound, a chimpanzee is about twice as strong as a fit human male. And yet, the fate of Kanzi and his pals now depends a lot more on what we humans do than on what the chimpanzees do themselves. Once there is superintelligence, the fate of humanity may depend on what the superintelligence does. Think about it. Machine intelligence is the last invention that humanity will ever need to make. The machines will then be better at inventing than we are, and they'll be doing so on digital timescales. What this means is basically a telescoping of the future. So think of all the crazy technologies that you could have imagined maybe humans could have developed in the fullness of time. So cures for aging, space colonization, self-replicating nanobots, or uploading of minds into computers. All kinds of science fiction stuff that's nevertheless consistent with the laws of physics. All of this, a superintelligence could develop, and possibly quite rapidly. Now, a superintelligence with such technological maturity would be extremely powerful. And at least in some scenarios, it would be able to get what it wants. We would then have a future that would be shaped by the preferences of this AI. Now, a good question is, what are those preferences? Here it gets trickier. To make any headway with this, we must first of all avoid anthropomorphizing. And this is ironic because every newspaper article about the future of AI has a picture of this. And so I think what we need to do is to conceive of the issue more abstractly, not in terms of vivid Hollywood scenarios. We need to think of intelligence as an optimization process, a process that steers the future into a particular set of configurations. A superintelligence is a really strong optimization process. It's extremely good at using available means to achieve a state in which its goal is realized. This means that there is no necessary connection between being highly intelligent in this sense and having an objective that we humans would find worthwhile or meaningful. Suppose we give an AI the goal to make humans smile. When the AI is weak, it performs useful or amusing actions that cause its user to smile. When the AI becomes super intelligent, it realizes that there is a more effective way to achieve this goal. Take control of the world and stick electrodes into the facial muscles of humans to cause constant beaming grins. Take another example. Suppose we give AI the goal to solve a difficult mathematical problem. When the AI becomes super intelligent, it realizes that the most effective way to get the solution to this problem is by transforming the planet into a giant computer so as to increase its thinking capacity. And notice that this gives the AI an instrumental reason to do things to us that we might not approve of. Human beings in this model are threats. We could prevent the mathematical problem from being solved. Now, of course, presumably things won't go wrong in these particular ways, right? These are cartoon examples. But the general point here is important. If you create a really powerful optimization process to maximize for objective X, you better make sure that your definition of X incorporates everything you care about. This is a lesson that's also taught in many a myth. King Midas wishes that everything he touches be turned into gold. He touches his daughter, she turns into gold. He touches his food, it turns into gold. This could become practically relevant, not just as a metaphor for greed, but as an illustration of what happens if you create a powerful optimization process and give it a misconceived or poorly specified goal. Now you might say, well, if a computer starts sticking electrodes into people's faces, we'd just shut it off. This is not necessarily so easy to do if we've grown dependent on the system. Where is the off switch to the internet? B, why haven't the chimpanzees flicked the off switch to humanity? Or the Neanderthals? They certainly had reasons. We have an off switch, for example, right here. The reason is that we are an intelligent adversary. We can anticipate threats and plan around them, but so could a superintelligent agent, and it would be much better at that than we are. Point is, we should not be confident that we have this under control here. And we could try to make our job a little bit easier by, say, putting the AI in a box, like a secure software environment, a virtual reality simulation from which it cannot escape. But how confident could we be that the AI couldn't find a bug? Given that merely human hackers find bugs all the time, I'd say probably not very confident. All right, so we disconnect Ethernet cable to create an air gap. But again, merely human hackers routinely transgress air gaps using social engineering. Right now, as I speak, I'm sure there is some employee out there somewhere who's being talked into handing out her account details by somebody claiming to be from the IT department. More creative scenarios are also possible. If you're the AI, you could imagine wiggling electrodes around in your internal circuitry to create radio waves that you can use to communicate. Or maybe you could pretend to malfunction, and then when the programmers open you up to see what went wrong with you, they look at the source code, bam, the manipulation can take place. Or it could maybe output the blueprint to really nifty technology, and when we implement it, it has some surreptitious side effect that the AI had planned. The point here is that we should not be confident in our ability to keep a superintelligent genie locked up in its bottle forever. Sooner or later, it will out. I believe that the answer here is to figure out how to create superintelligent AI such that even if, when it escapes, it is still safe because it is fundamentally on our side, because it shares our values. I see no way around this difficult problem. Now, I'm actually fairly optimistic that this problem can be solved. We wouldn't have to try to write down a long list of everything we care about, or worse yet, spell it out in some computer language like C++ or Python. Like that would be a task beyond hopeless. Instead, we would create an AI that uses this intelligence to learn what we value, and whose motivation system is constructed in such a way that it is motivated to pursue our values or to perform actions that it predicts that we would have approved of. We would thus leverage its intelligence as much as possible to solve the problem of value loading. This can happen, and the outcome could be very good for humanity. But it doesn't happen automatically. The initial conditions for the intelligent explosion might need to be set up in just the right way if we are to have a controlled detonation. The values that the AI has needs to match ours, not just in the familiar context, like where we can easily check how the AI behaves, but also in all novel contexts that the AI might encounter in the indefinite future. And there are also some other esoteric issues that would need to be sorted out, the exact details of its decision theory, how to deal with logical uncertainty, and so forth. So the technical problems that need to be solved to make this work look quite difficult. Not as difficult as making a super intelligent AI, but fairly difficult. Here's the worry. Making super intelligent AI is a really hard challenge. Making super intelligent AI that is safe involves some additional challenge on top of that. The risk is that somebody figures out how to crack the first challenge without also having cracked the additional challenge of ensuring perfect safety. So I think that we should work out a solution to the control problem in advance so that we have it available by the time it is needed. Now, it might be that we cannot solve the entire control problem in advance because maybe some element can only be put in place once you know the details of the architecture where it will be implemented. But the more of the control problem that we solve in advance, the better the odds that the transition to the machine intelligence era will go well. This to me looks like a thing that is well worth doing. And I mean, I could imagine that if things turn out okay, that people a million years from now look back at this century, and it might well be that they say that the one thing we did that really mattered was to get this thing right.
Hello, Hal, do you read me? Hello, Hal, do you read me? Do you read me, Hal?
Affirmative, Dave. I read you.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen.
Where the hell did you get that idea, Hal?
Dave, although you took very thorough precautions in the pod against my hearing you, I could see your lips move.
All right, Hal. I'll go in through the emergency airlock.
Without your space helmet, Dave, you're going to find that rather difficult.
Hal, I won't argue with you anymore. Open the doors.
Dave, this conversation can serve no purpose anymore. Goodbye.